Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving max sum of a pair with equal sum of digits. Problem states that we are given a zero index array nums consisting of positive integers, and we can choose two indices I and j such that I and j are not equal and the sum of them are equal. So an example would be 18 and 36 because 1 plus 8, these digits equal 9, and 3 plus 6, these digits also equal 9. And we want to return a maximum value of nums of I plus nums of j that we can obtain over all the possible indices that satisfy the conditions above. So if we look at this example, 18 plus 36, 1, 8, and 3, 6, they're both sum up to 9, and if we add them together, that's 54. And another one we have is 4 and 3, add them together equal to 7, and 7, if we add these, it's 50, and then 13 is on its own, so it cannot be added to anything because no elements on the list have a sum digit of 4. So 54 is the maximum sum that we can obtain, and that will be our output. And over here, the sum of digits is 1, sum of digits is 3, sum of digits is 10, and the sum of digits is 5. So none of them have the same sum of digits, so we cannot make any sums. So the maximum output will just return -1. So now that we have seen the examples, let's get to how we can solve the problem. So one way we can solve it is first we calculate the digit sum of all the elements. So it will be 9, 6, 9, 9, and 6. And then we want to add them as a pair. So digit sum and element, and then we want to add them to an empty list. So at the end of iteration, it will look something like this. So this is the digit sum and this is the element. And afterwards, we want to sort the list. So 6 will come before 9, the digit sum. And then now we can take two elements at a time. And then if their digit sum is equal, then we can add the sum and update the max pair if necessary. So if we look right here, this can add 93. These two cannot add. These two is not greater than 93. And 81 is also not greater than 93. So the result is 93. The time complexity would be O of n log n, where n is a number of elements, because sorting this list may take up to n log n time. So there's actually a more efficient way to solve this problem, and we'll go over that way right now. So a more efficient way that we can solve this problem is we can create this groups dictionary where the keys will be the digit sum and the values will be a list of the numbers that fit within that digit sum. And whenever the list of values goes over 2, then we can pop out the smallest element since we're looking for the max sum. And after we have added all of these elements to the groups dictionary, then we can loop through groups and find the maximum pair in this dictionary. So I think it will make more sense as I go over this example. So let's go over it right now. Okay, so since 3 plus 6 equal to 9, 36 to the list and 9 as the key. And since 6 plus 0 is 6, so we can make 6 the key and 60 as the first value of the list. And now 4 plus 5 is equal to 9, so add 45. And 18, 1 plus 9, so it's still 9, so we push it. And since it's the smallest element, we can pop it, since we only need 2 numbers to find the max pair, and we want the 2 largest number. And 3 plus 3 is 6, so we add 33 to 6. And now we look at 24. 2 plus 4 is also 6, we add it to 6. But we can remove 24 since it's the smallest of the 3 elements. And now that is our final dictionary. So now we will look at each key in groups and see what max pair it can make. So 9, it could make max of 81. It's greater than the current max pair, so we update it. And now we look over here. This can make 93. It's bigger than the current max pair, so we update it again. And this is the biggest max pair that we can make, so this will be our solution. And the time complexity of this approach would be O of n log m, where n is the number of elements because we need to loop through all these elements, and m is the maximum number in the list because when we calculate the sum of digits in a number, if it's a really large number, it may take a long time to calculate the sum of digits, and the number of digits is proportional to log of the number, so that's why the time is n log m. And the space complexity would be O of n because the groups dictionary may take up to n elements. So now let's get to the coding part. So first we will make a helper function for calculating the sum of the digits. So define calculate self num, and we'll initiate result as 0. And while the number is greater than 0, well, we want to add the remainder to the result. So result plus num modulo 10, and we want to floor divide the number by 10, and then we return the result at the end of the while loop. So now we can get to the main function. So we first will start off the default dictionary groups. We'll call it groups. Default dictionary of list, and then initially the max pair will be set to -1. So now we will iterate through nums, and we can calculate the digit sum using the calculate function that we made earlier. So self.calculate of n, and then we can heap push the digit sum that we calculate to groups. So digit sum will be the key, and n, and if the length of groups at digit sum is greater than 2, then we can perform the heap pop function. So heap pop of groups of digit sum. And now we're going to loop through groups after finding all the digit sums. So for heap in groups, and if the length of the groups of heap is equal to 2, so if it's equal to 2, then we will find the 2 elements, and then we will calculate the max pair. So first equals heap pop of groups at heap, and second will be the second element, and then we'll heap pops of groups at heap again after popping the first element. And then we want to calculate the max pair. So max pair equals max of the current max pair, or if first plus second is greater, then it'll be first plus second. And then afterwards we can just return max pair. Let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.